All right, every single one of us has been there, right? You hit run, you hold your breath, and boom, crash. But what if I told you the best programmers have a secret? They don't just fix errors, they expect them. Today we're going to dive into how you can build code that's not just working, but is basically bulletproof.
I mean, really, think about it. Imagine your code is a high-wire acrobat. Without a net, one tiny slip, and it's all over. But if you plan for that stumble, if you have that safety net in place, it's not a disaster. It's just part of the act. That's the huge difference between fragile code and the kind of resilient software we're getting into.
So you're probably thinking, man, there are 1,000,001 ways my code can break. And it feels that way, for sure. But here's the crazy part. Pretty much every single error you'll ever see falls into just 3 main buckets. And once you get these 3, you're on your way to mastering the whole game.
Okay, so what are they? Here we go. Syntax, logical, and runtime errors. That's it. Every frustrating bug, every late-night crash, it all fits into one of these. Let's break them down real quick.
All right, syntax errors, those are just typos, right? It's like bad grammar. The computer literally just goes, I have no idea what you're saying. Then you've got logical errors. This one's a bit sneakier. It's like you gave perfect step-by-step directions, but to the completely wrong place. The code runs fine, it just does the wrong thing. Now, we usually find these two while we're building stuff, but that third one, the runtime error, oh man, that's the one that causes the real headaches.
Yeah, see, runtime errors, this is where your beautiful, perfect code has to face the messy, unpredictable real world. You know, a network cable gets kicked out, a file you needed suddenly vanishes, or a user, being a user, types 25 instead of 25. These are the things that make software fragile. These are the moments that can bring your entire application grinding to a halt.
So, in the world of programming, we actually have a special name for these runtime surprises. We call them exceptions. And this is a huge mental shift, okay? You have to stop thinking of them as just bugs. Start seeing them for what they really are, a message. It's your program trying to talk to you.
So what is an exception, really? Well, under the hood, it's just an object. But it's an object that your program raises or throws into the air when it hits a wall and just can't continue its normal step-by-step flow. It's a deliberate, full-stop interruption. It's a giant flashing red light that says, Houston, we have a problem.
And yeah, this is the perfect way to think about it. It is literally your program raising its hand and saying, whoa, 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 I cannot continue like this. It's hitting the emergency brake and yelling, hey, you told me to divide by 0. I can't do that. You got to deal with this. And everything stops, waiting for you, the programmer, to do something about it.
Okay, so if our code is going to raise its hand and stop the show, how are we supposed to respond? Well, this is where we build that safety net we were talking about. There's a structure for this, a way to catch these interruptions and handle them gracefully so the whole thing doesn't just, explode.
And check this out. This is the magic right here. On the left, dead simple code, 10 divided by 0. What happens? Crash and burn. Program over. But look at the right. We wrap that exact same risky code in what's called a try-except block. We try to do the division. We know it might fail with a 0 division error, so we tell it what to do if it catches that specific error. The error technically still happens, but our program doesn't crash. It has a safe landing. Huge difference.
And the structure itself is it's so logical. It's beautiful. Step 1, you try a piece of code that you think might be a little risky. Step 2, you have an except block waiting. It's the catcher's mitt. If a specific error pops up in that try section, this is the code that runs instead of a crash. And then there's a third optional piece called finally, and this guy is super important for cleanup.
Yeah, think of the finally block as your cleanup crew. It doesn't care if the try block worked perfectly or if it blew up. It runs no matter what. And this is absolutely critical for things like, say, closing a file you opened or shutting down a database connection. Because if you don't do that stuff, you can end up with memory leaks, corrupted data, just a whole world of pain that is an absolute nightmare to debug later.
Okay, now here's a super important pro tip. It is so tempting to just write a generic except block that catches any and every error. But please don't do it. It's a really bad habit. Why? Because you might end up accidentally catching and silencing a totally different bug you didn't even know was there. And now it's hidden, making your life way, way harder down the road. So rule of thumb, always be specific about the errors you're catching.
You know, handling exceptions isn't just about a chunk of code. It's actually a whole philosophy. Especially in a language like Python, there are 2 big schools of thought on how to deal with things that might go wrong, and they come from totally different mindsets. So on one side, you have look before you leap, or LBYL. This is the cautious approach. You check everything first. Hey, does this file exist? Okay, good. Now I'll open it. Hey, is this number not 0? Cool. Now I'll do the division. Then you have the other side. Easier to ask for forgiveness than permission, or EAFP. With this, you just go for it. Just try to open the file. Just try to do the division. And if a problem happens, well, that's what your accept block is for.
And in the Python community, we really live by that second one, EAFP. It's what we call Pythonic. And the reason is that it just leads to cleaner, more readable code. Instead of nesting a bunch of if checks everywhere, you write optimistic code. You assume it's going to work, and then you elegantly handle the cases where it doesn't. It's just a cleaner way to think.
Okay, so this whole philosophy is powerful stuff. But what if the built-in errors, the standard value error or file not found error, what if they just aren't specific enough for your program? What if you have a business rule that gets broken? Well, this is where you level up. You stop just handling exceptions and you start creating them. You get to forge your own tools.
And honestly, this is a total game changer. When you create your own custom exceptions, you can send out super specific signals that are unique to your app. It makes your code so much more descriptive and, believe me, way easier for you and anyone else on your team to understand and debug later on.
And the best part is, it sounds complicated, but it's ridiculously simple. For real. All you do is create a new class, give it a really clear name like invalid transaction error or something, and just tell it to inherit from the main exception class. Boom, done. You've just invented your own custom error signal.
So what this really does is it takes your error handling from being generic to being incredibly specific and communicative. I mean, it's the difference between a generic warning light in your car that just says engine versus a specific message that says, warning, tire pressure is low in the rear left tire. One is way more useful, right? That's what you're doing for your code.
So look at that. We've totally come full circle. We started out with that sinking feeling of your code just crashing. And now you have the tools and the mindset to build applications that don't just work. They can actually withstand the chaos of the real world. You're not just a coder anymore. You're an architect. You're building robust systems. So the only question left is, what exceptional code are you going to write?